Now friends, we have completed 2 units. First was 3-phase circuits. Second was DC machines, in which we covered DC generators as well as DC motors. And now third unit, very important unit, which everyone should know about it, and that one is transformer. Transformer. I am defining transformer first. A static piece of device. Transformer, it will transform. A static piece of device that transforms electrical energy from one circuit to other circuit. Transformation. Transformer, its name is transformer. Transformation of electrical energy from one circuit to other circuit with desired change in voltage and current, but no change in frequency. A static piece of device that transfers electrical energy from one circuit to other with desired change in voltage and current, but no change in frequency. Energy means a sinusoidal energy. From one circuit to another circuit, the energy can be transferred with desired change in voltage and current. That means to one circuit, voltage is having some magnitude. That magnitude can be increased or decreased while transforming it to other circuit. One circuit may be having some current. While transforming it to other circuit, that current may be increased or decreased. Magnitude of voltage and current can be increased or decreased while it is transferred from one circuit to other circuit. But there will be no change in frequency. Is that clear? Transformer, transformation. What will it transform? It will transform electrical energy from one circuit to other circuit. While transforming that energy, the voltage and current of that energy can be increased or decreased, but frequency remains unchanged. Right? So the definition is a static piece of device that transforms electrical energy from one circuit to other circuit with a desired change in magnitude of voltage and current. Desired change. Magnitude of voltage and current can be increased or decreased. Desired change in magnitude of voltage and current, but no change in frequency, that is transformer. Right? So I am drawing transformer symbolically. This is the magnetic circuit over which two coils are placed. This is flux phi, primary voltage V1, primary current I1, secondary voltage V2, and secondary will draw current when load is connected. That will be I2. Secondary will draw current when load is connected. Right? So this is induced EMF in primary, this is induced EMF in secondary. So transformer works on the principle of electromagnetic induction. And there are two important terms, self-induction and mutual induction. So transformer basically has two coils. This is first coil, this is second coil. The coil which is connected to supply, V1 is the supply. That is known as primary coil. And the load is connected across secondary. That is known as secondary coil. So transformer is represented by two coils. The coil which is connected to supply is known as primary coil, and the coil across which load is connected, here we will connect load, that is secondary coil. So primary coil, self induction, secondary mutual induction. E1 is self induced EMF, E2 is mutually induced EMF. What is meant by mutual induction? One coil induces EMF in other and vice versa. That is mutual induction. So when supply V1 is provided, current I1 flows through it. That current sets a flux in the coil, flux phi in the coil. When flux is set up, induced EMF is generated, d phi by dt. We have studied it in previous article. When flux is set up, induced EMF is set up, E1. So E1 is self-induced EMF of primary, 1 for primary, 2 for secondary. E1 is self-induced EMF of primary. So when V1 is provided, I1 flows, it sets a flux in the winding that induces EMF E1. E1 induces mutually induced EMF E2. E1 induces mutually induced EMF E2. So E1 is self-induced EMF, E2 is mutually induced EMF. And then secondary carries current I2 when load is connected, and it produces voltage V2. For V2 and I2, it is essential to connect load. V1 is provided, I1 flows, it sets up phi, it induces E1, self-induced EMF, E1 induces E2, mutually induced EMF, and then secondary carries current I2 when load is connected, and then V2 is produced. That is the sequence. Right? Principle of working of transformer. It works on the principle of mutual induction. There are two terms, self-induced and mutually induced. Self-induced means EMF induced in the coil itself. Mutual induced means EMF induced by one coil in other coil. E2 is due to E1. E1 induces EMF E2. That is mutually induced EMF. So the sequence is clear, right? Now we will study EMF equation of transformer. Important, the question can be asked in the exam. EMF equation of transformer. So EMF equation of transformer, I have taken a sine wave, induced EMF. Omega t is x-axis. This is complete period t. This is half cycle t by 2. So this is quarter cycle t by 4, and t is equal to 1 by f. So it is 1 by f. This is 0. This is flux axis. So this is maximum value of phi. That is phi. Right? So maximum value occurs at, this is half cycle, occurs at quarter cycle t by 4, and t is 1 by f, 1 by 4. So we know, we have studied this in previous article. EMF per turn EMF induced per turn will be d phi by dt, right? D phi, change in flux, dt, change in time. Flux is changing from 0 to phi m, and time is changing from 0 to t by 4. So d phi is phi m minus 0. At phi m, time is t by 4, at 0, time is 0, and then it is t by 4 minus 0. So it will be phi m upon 1 by 4f is equal to 4f phi m. So this is average EMF. This is average EMF per turn. 4f phi m. Right? Average EMF per turn. Now, since this is a sine wave, we need to define its RMS value. So we know RMS value upon average value is form factor. Right? RMS value upon average value is form factor. Form factor is constant 1.11. So RMS will equal to 1.11 into average. So RMS EMF per turn will be 1.11 into average EMF per turn. So RMS EMF per turn is equal to 1.11 into average EMF per turn is this one, 4f phi m. So it is 4.44 F phi m. Now, if we want to write this equation for primary, then number of turns on primary is N1. If N1 turns on primary and N2 turns on secondary, then E1 RMS EMF, E1 is RMS EMF. Per turn I am reviewing, number of turns are N1, so I will multiply this by N1. For EMF I am writing E and primary, so E1 per turn, so I am multiplying this equation by N, then it will be 4.44 F phi m N1. This is general equation. Now for number of turns on primary is N1, so E1 will be multiply this by N1, E2 will be multiply this by N2, and E2 will be 4.44 F phi m N2. Right? So if we take the ratio, E2 by E1 is equal to N2 by N1. Right? Now we have just studied a diagram above where V1, E1, V2, E2, I1, I2 are indicated. So for ideal transformer, V1 is equal to E1 and V2 is equal to E2. For ideal transformer, V1 is equal to E1 and V2 is equal to E2. So we get V2 by V1, V2 upon V1 equal to E2 upon E1 equal to N2 by N1. Right? So first I have written equation for primary induced EMF, secondary induced EMF, their ratio. Then in above diagram we have drawn V1, E1, V2, E2, I1, I2. So if the transformer is ideal, then V1 will be equal to E1, V2 will be equal to E2. So V2 by V1 will be E2 by E1, and that is N2 by N1. Now, one more relation. For ideal transformer, input volt ampere rating is always equal to output volt ampere rating. For ideal transformer, input volt ampere rating is always equal to output volt ampere rating. Volt ampere, voltage into current. So input VA is V1 into I1 is always equal to output VA. Output voltage is V2, output current is I. So if we take the ratio, V2 by V1 is equal to V2 upon V1 will be I1 upon I2. So if this is put here, then we get V2 by V1 is equal to E2 by E1 is equal to I1 by I2 is equal to N2 by N1. Suppose N2 by N1 I am indicating as K. V2 by V1 is equal to E2 by E1. V2 by V1 is equal to I1 by I2. So I1 by I2, and that is equal to N2 by N1. This is known as transformer turns relation. Very important. Keep in mind, this will be useful in next articles. V2 by V1 will be equal to E2 by E1. For current it is reverse, I1 by I2. Here it is V2 by V1, E2 by E1, but it is reverse, I1 by I2. Again N2 by N1, and N2 by N1 I am representing as K. Right? So we will study three cases. First case, number of turns N2 on primary, secondary are less than primary. If N2 is less than N1, then V2 will be less than V1. Then I1 will be less than I2. N2 less than N1, it means that V2 less than V1, it means that I1 less than I2, it means that K is less than 1. First case, N2 less than N1 will be V2 less than V1, it will be I1 less than I2, K less than 1. This is known as step down transform. Second, exactly opposite. N2 greater than N1, it means that V2 will be greater than V1, it means that I1 will be greater than I2, it means that K will be greater than 1, that is step up transform. And third case, if N2 is equal to N1, it means that V2 will be equal to V1, it means that I1 will be equal to I2, it means that K will be equal to 1, that is known as isolation transform. So from this relation we have studied three cases. V2 less than V1 will be N2 less than N1, will be I1 less than I2, will be K less than 1, step down. V2 greater than V1, N2 will be greater than N1, I1 will be greater than I2, K greater than 1, step up transformer. N2 is equal to N1, V2 will be equal to V1, I1 is equal to I2, K is equal to 1, isolation. Right? So in next article we will study transformer under no load and load conditions and their vector diagrams. Is that clear? I will provide all the notes of unit 3 in PDF format. While observing the video, carefully observe it, carefully listen it, carefully observe the notes, and please, I am repeating again and again in every lecture, note it down in your notebook in your own handwriting. Okay?